Deep inside our solar system, the crown jewel of our sky is quietly bleeding to death. Thousands of tons of icy water are tearing away from Saturn every single second, pulled downward by an invisible magnetic grip. The most famous, dazzling ring system known to humanity is being swallowed whole by its own mother planet. What was once thought to be an eternal cosmic landmark is actually vanishing right before our eyes. If you love exploring the quiet truths of our universe without the fake drama or wild hype, take a quick moment to hit subscribe. We track real science and deep space mysteries every single week, so you never miss what is actually happening out there in the dark. For hundreds of years, humans looked up at Saturn and assumed its glowing halo was a permanent fixture of the night sky. When Galileo Galilei first pointed a primitive wooden spyglass at Saturn in the summer of 1610, he was completely baffled by what he saw. The optics on his small telescope were rough and blurry, making the planet look like it had two giant ears or handles sticking out from its sides. He wrote in his personal letters that Saturn seemed to be a triple-bodied entity made of three spheres touching one another. He had no idea he was looking at an impossibly thin disk made of billions of chunks of frozen water. A couple of years later, Galileo looked back through his lens and suffered an even bigger shock. The strange ears had completely vanished, leaving Saturn looking like a plain, lonely ball hanging in the blackness. He jokingly wondered if the ancient mythological god Saturn had swallowed his own children, unable to explain why the structures were gone. What Galileo did not understand was that Saturn tilts as it travels along its long 29-year orbit around the Sun. When the rings tilt directly edge-on toward Earth, they are so remarkably thin that they become completely invisible to basic telescopes. It was not until the year 1655 that a Dutch astronomer named Christian Huygens built a telescope with much sharper glass. Huygens figured out that Saturn was surrounded by a solid, flat, detached ring that never touched the planet itself. Then, 20 years later in 1675, an Italian astronomer named Giovanni Domenico Cassini discovered a dark, empty lane splitting the bright ring in two. That dark gap, which we still call the Cassini division today, proved the ring was not one single solid piece of rock. Slowly, humanity began to realize that Saturn was surrounded by something far more delicate and complex than a solid stone hoop. Over the next century, other stargazers noticed more fine divisions within the broad rings. They saw subtle shifts in brightness and tiny dark streaks that appeared and disappeared over weeks of observation. Still, most people assumed the rings were rigid sheets of stone, crystal, or metal spinning smoothly through space. The sheer size of the structure seemed to demand immense structural strength. If something was hundreds of thousands of kilometers across, everyday human intuition insisted that it had to be thick and solid. In the late 19th century, a Scottish physicist named James Clerk Maxwell proved mathematically that a solid ring would be torn to pieces by Saturn's intense gravity. Maxwell calculated that the only way the rings could exist without crashing into the planet was if they were made of trillions of tiny, independent particles. Each individual particle had to be acting like its own miniature moon, speeding along in its own tidy orbit. Maxwell showed that particles closer to Saturn must orbit faster, while particles farther out must move slower. When modern space probes finally reached the outer solar system in the late 20th century, they confirmed Maxwell was entirely correct. When NASA launched the twin Voyager 1 and Voyager 2 spacecraft in 1977, planetary scientists were ready to see the rings up close for the first time. The Voyager flybys in 1980 and 1981 sent back high-resolution photographs that shocked the world with their mind-boggling complexity. Instead of just 2 or 3 simple rings, Voyager revealed thousands of individual ringlets, looking like the tiny grooves on an enormous vinyl record. The entire structure stretched across a distance of roughly 280,000 kilometers, which is more than 20 times wider than planet Earth. Yet even with that enormous width, the rings turned out to be shockingly paper-thin. In most places, the main rings are only about 10 meters thick, which is roughly the height of a 2-story suburban family home. If you shrank Saturn down to the size of a standard classroom globe, the rings would be thousands of times thinner than the sharpest razor blade you could buy. The Voyager spacecraft also revealed that these rings are not dirty gray space rocks, but almost pure, shimmering water ice. Over 99% of the material reflects sunlight like freshly fallen winter snow on a bright morning. The individual particles that make up this brilliant sheet vary wildly in size from one zone to another. Some pieces are microscopic specks of frozen dust no larger than a grain of baking flour. Other pieces are the size of marbles, golf balls, and large ice cubes floating quietly side by side. Scattered throughout the rings are massive icy boulders as large as family cars, buses, and entire apartment buildings. These trillions of pieces bump gently into one another at walking speed, maintaining a smooth, flat disk through constant collisions. For decades after the Voyager flybys, astronomers believed these rings had been circling Saturn since the birth of our solar system 4.6 billion years ago. The general consensus was that when the giant planets formed from a swirling cloud of gas and dust, leftover icy debris simply settled around Saturn and stayed there forever. It was a comforting and majestic idea, painting Saturn as an eternal giant that had always looked just as it does today. But buried inside the Voyager radio signals was a faint, confusing clue that something strange was happening in Saturn's upper clouds. Have you ever wondered what the night sky would look like from Earth if our own planet had giant icy rings stretching from horizon to horizon? Drop a comment below with what you think life would be like under glowing rings, and make sure to like the video if you love discovering these hidden space secrets. That tiny clue from the Voyager data was something astronomers called ring rain. When Voyager passed by the planet, its instruments detected dark, warm bands spreading across Saturn's upper atmosphere, specifically along the magnetic field lines. Scientists like Dr. Jack Connerty at NASA Goddard Space Flight Center suggested that water from the rings might be falling straight down into the clouds. However, because Voyager only zoomed past Saturn in a matter of days, nobody could prove how much water was actually falling or if the rings were truly in danger. The idea remained an unproven theory tucked away in academic journals for over 3 decades. During those intervening decades, planetary scientists debated how such a massive drainage could even operate on a physical level. The rings seemed to sit peacefully in stable orbits, perfectly balanced between the pull of gravity and centrifugal force. Without a direct mechanism to pull that ice downward, many researchers believed the rings were completely safe from destruction. They argued that the dark bands detected by Voyager were simply atmospheric quirks caused by internal heat rather than falling water. The mystery sat unresolved, waiting for a dedicated explorer to take up orbit around the planet. Everything changed when NASA, the European Space Agency, and the Italian Space Agency teamed up to send the Cassini-Huygens spacecraft to Saturn. Arriving in the summer of 2004, Cassini spent 13 long years orbiting the ringed giant, studying every single cloud belt, icy moon, and shimmering gap. It carried specialized spectrometers and dust analyzers designed to sniff the chemical composition of the space surrounding Saturn. What Cassini discovered turned the old timeline on its head and completely rewrote planetary science textbooks around the world. To understand why the rings are vanishing, you have to look closely at what is happening to each tiny grain of ice. Out in the vacuum of space, Saturn's rings are continuously blasted by intense ultraviolet radiation pouring out from the sun. At the exact same time, tiny space rocks called micrometeoroids, often no larger than grains of beach sand, slam into the icy ring particles at blistering speeds. These collisions and radiation strikes knock electrons off the water molecules, giving the icy grains a positive electrical charge. Once an ice particle gains an electric charge, the rules of its motion completely change. Before gaining that charge, the particle only cared about gravity, happily coasting in a balanced circular orbit around Saturn at thousands of miles per hour. But as soon as it becomes electrically charged, it feels the immense magnetic field of Saturn, which reaches out thousands of kilometers into empty space. Saturn's magnetic field lines curve directly out of the planet's southern hemisphere and loop all the way back into its northern hemisphere. The charged ice dust suddenly gets caught in this invisible magnetic highway. Gravity tries to pull the ice straight toward the center of the planet, while orbital speed tries to fling the ice outward into the void of space. Under normal circumstances, those two forces balance each other out perfectly. But Saturn's magnetic field breaks that balance, tilting the pull and dragging the charged water ice along the magnetic field lines. The particles begin a long downward slide, spiraling down the magnetic curves straight into Saturn's churning atmosphere. This constant invisible downpour is the phenomenon known as ring rain. As these charged ice crystals spiral downward along the magnetic pathways, they gather tremendous speed. They plunge through the planet's upper atmosphere, known as the ionosphere, where they collide violently with gaseous hydrogen and helium. The sheer friction of this atmospheric entry flash heats the ice, turning the frozen crystals instantly into hot water vapor. This influx of foreign water reacts violently with the surrounding gases, fundamentally altering the chemistry of Saturn's upper sky. Before Cassini arrived, scientists guessed that ring rain was just a slow, gentle trickle that barely made a dent in the massive ring system. They believed the rings held enough mass to easily survive this tiny leak for billions of more years. But as Cassini spent more time analyzing the inner rings, it noticed that the innermost D ring and C ring were strangely depleted of material. It looked as if an enormous invisible vacuum cleaner was actively sucking the material out of the inner regions at an alarming rate. The data revealed that the inner rings were surprisingly transparent, containing far less solid ice than the outer B and A rings. If the rings had been draining at a slow, harmless rate for billions of years, the distribution of ice across the entire system should have been relatively uniform. Instead, Cassini found sharp boundaries, depleted inner lanes, and strange, ghost-like ripples running through the structure. These ripples indicated that massive amounts of matter had vanished very recently in cosmic time. In the final months of its mission in 2017, NASA decided to execute a daring, dangerous flight plan called the Grand Finale. With its fuel tanks running on fumes, Cassini was commanded to dive directly through the narrow gap between Saturn's cloud tops and the innermost edge of the rings. No spacecraft had ever dared to fly through this region before because any rogue ice boulder could have smashed the probe to pieces instantly. Over 22 fearless orbits, Cassini dipped lower and lower, tasting the space just above Saturn's swirling storms. What Cassini discovered during those final dives shocked the mission engineers sitting in the control room at NASA's Jet Propulsion Laboratory. The instruments detected that Saturn was not just receiving a light drizzle of charged water particles along its magnetic lines. It was experiencing a torrential, crushing downpour of material falling directly along the planet's equator. The inner rings were dumping an unimaginable amount of water, methane, carbon monoxide, and organic dust straight down into the clouds. Did you expect that a giant planet could actually destroy its own rings in such a short cosmic time frame? Tell us in the comments what surprised you most about this process, and consider subscribing if you want genuine, straightforward breakdowns of our solar system's biggest events. The instruments on Cassini measured that between 400 and 2,800 kilograms of ring material was crashing into Saturn every single second. To put that number into perspective, that is the equivalent of an entire Olympic-sized swimming pool full of water dumping out of the sky every half hour. Every single day, Saturn consumes millions of kilograms of its own beautiful halo. The planet is literally eating its most defining feature, devouring the rings from the inside out. The composition of this falling material was another massive surprise for the scientific community. Researchers had assumed the rain would be almost pure water ice, matching the visual purity of the main rings. But the ion and neutral mass spectrometer aboard Cassini found complex organic molecules, tiny soot particles, silicate dust, and volatile chemicals mixed into the downpour. This meant the rings were acting like an immense chemical factory, trapping interstellar dust and cosmic debris before funneling it straight into Saturn's core. This staggering rate of destruction forced scientists to confront a massive puzzle about the true age of the rings. If the rings are losing material this fast, they could not possibly have existed for 4.6 billion years. If they were that old, they would have completely drained away long before the first single-celled life forms even appeared on planet Earth. Dr. James O'Donoghue, a planetary scientist who worked at NASA Goddard and later the Japan Aerospace Exploration Agency, led groundbreaking studies analyzing this drainage. His team used the giant Keck telescopes sitting atop the dormant Mauna Kea volcano in Hawaii to track the water inside Saturn's atmosphere from Earth. By measuring the infrared glow of a specific hydrogen ion called H3+, Dr. O'Donoghue could see the exact footprint where the ring rain was hitting the atmosphere. Wherever the water ice crashes into Saturn's hydrogen-rich clouds, it triggers a chemical reaction that dims the glow of this specific ion. The Keck observations revealed dark, glowing bands across huge swaths of Saturn, matching the exact locations where the magnetic field lines connect the rings to the planet. The ground-based telescope data matched Cassini's in-space measurements with terrifying accuracy. The infrared mapping showed that the northern and southern hemispheres were drinking ring water at slightly different rates. The southern hemisphere was absorbing a heavier deluge because of how Saturn's magnetic axis aligns with its physical rotation. The Keck observations confirmed that this was not a localized storm or a brief weather anomaly. It was a planet-wide phenomenon operating on an immense industrial scale, draining entire oceans of water out of orbit every few thousand years. The numbers were so clear that scientists had to completely reevaluate the mass of the rings. During the grand finale, Cassini flew between the rings and the planet, allowing scientists on Earth to track the tiny gravitational tugs on the spacecraft's radio signal. This allowed them to weigh the rings with incredible precision for the first time in human history. The total mass of the rings turned out to be much lower than anyone had previously thought, weighing only about 40% of Saturn's tiny frozen moon mimas. For decades, many astrophysicists argued that the rings were heavy and massive, perhaps containing as much matter as a medium-sized icy moon several hundred kilometers wide. A massive ring system could theoretically withstand billions of years of slow erosion without disappearing entirely. But Cassini's gravity measurements demolished that theory in an instant. The rings were surprisingly light, delicate, and thin, lacking the raw mass required to survive across billions of years of cosmic history. A lower mass combined with a massive drain rate meant only one thing: the rings are incredibly young. Scientists now estimate that Saturn's rings are likely between 10 million and 100 million years old, while 100 million years sounds like an eternity in human terms. In the grand timeline of our solar system, it is nothing more than the blink of an eye. If the entire 4.6 billion year history of our solar system were compressed into a single 24-hour day, Saturn's rings formed less than 5 minutes ago. Think about what that simple fact really means for the history of our own planet. The dinosaurs, such as the famous Tyrannosaurus rex and the giant long-necked Brachiosaurus, roamed the Earth between 66 million and 200 million years ago. That means for almost the entire duration of the age of the dinosaurs, Saturn had no bright rings at all. If an alien astronomer had pointed a telescope at our solar system while a Stegosaurus was walking through a prehistoric forest, Saturn would have looked like a plain, boring yellow-brown ball, completely naked in the darkness. The rings are so young that they are effectively a modern addition to our solar neighborhood. When early mammals were beginning to scurry through the undergrowth of prehistoric forests, Saturn was just beginning to gather its icy halo. The bright spectacle that humans have celebrated in poetry, mythology, and science for centuries is actually a temporary flash in the dark. It appeared late in cosmic history, and it will vanish before the sun even begins to run low on nuclear fuel. If you had the chance to name a lost ancient moon of our solar system, what name would you pick? Leave your idea in the comments section below and take a second to hit that like button to help more science lovers find this story. This realization led to a new and urgent question that scientists are still debating fiercely. Where did these young rings come from in the first place? If they were not left over from the birth of the planet, something dramatic and violent must have happened in the Saturn system relatively recently. One leading theory suggests that an ancient icy moon, possibly similar in size to Saturn's large moon Titan, drifted too close to the planet. Every massive celestial body has an invisible boundary around it called the Roche limit, named after the French mathematician Edouard Roche. The Roche limit is the minimum distance to which a celestial body, held together only by its own gravity, can approach a second body without being torn apart by tidal forces. Saturn's gravity pulls much harder on the near side of an orbiting moon than it does on the far side. If a moon ventures inside this dangerous invisible boundary, that difference in gravitational pull becomes stronger than the moon's own internal strength. The moon is violently stretched, cracked, and ripped into billions of tiny icy fragments, which then spread out along the orbit to form a brand new, gleaming ring system. A team of researchers at the Massachusetts Institute of Technology, led by Professor Jack Wisdom, proposed a fascinating model involving a lost moon they nicknamed Chrysalis. According to their computer simulations, Chrysalis orbited Saturn peacefully for billions of years alongside the other moons. But several hundred million years ago, gravitational interactions with Titan destabilized Chrysalis's orbit, causing it to graze Saturn's outer atmosphere. And while the rocky core of Chrysalis plunged into the giant planet, its outer shell of pure water ice was sheared off, creating the bright rings we see today. This lost moon theory also neatly explains another long-standing cosmic puzzle: why Saturn tilts on its axis by 26.7 degrees. For years, scientists believed Saturn was gravitationally locked in resonance with the giant planet Neptune, which tilted Saturn over billions of years. But the MIT team proved that Saturn recently escaped that gravitational lock. The sudden loss of the moon, Chrysalis, gave Saturn a slight gravitational kick, breaking the lock with Neptune and leaving the planet tilted at the exact angle we observe today. Another alternative hypothesis suggests that a rogue giant comet from the distant Kuiper Belt wandered into the inner Saturn system. The Kuiper Belt is a frozen wasteland beyond Neptune, filled with trillions of icy bodies, some as large as dwarf planets. If a massive comet with an icy crust passed too close to Saturn, the planet's crushing gravity could have stripped the comet's outer layers into orbit while slinging its rocky core deep into interstellar space. Whether caused by a destroyed moon or a shredded comet, the rings were born from catastrophic violence. Once that debris was shattered into billions of pieces, the chaotic cloud did not remain a messy clump for very long. Over thousands of orbits, the fragments collided with one another, canceling out their random up and down motions and flattening into an ultra-thin circular disk. The internal gravity of the particles smoothed the edges, while tiny embedded moonlets carved out neat, sharp gaps. In a remarkably short geological time frame, a violent cosmic collision transformed into the most orderly and peaceful-looking structure in the solar system. Yet the same laws of physics that created that disk are now tearing it down without mercy. The tiny shepherd moons that keep the ring edges crisp, like Prometheus and Pandora, are constantly exchanging orbital energy with the surrounding ice. While these small moons help hold specific ringlets together, they also kick stray particles into chaotic orbits, where they become far more vulnerable to solar radiation and magnetic capture. The entire system is engaged in a delicate, losing tug-of-war against Saturn's magnetic field. Now, humanity has deployed its most advanced space observatory to uncover the next chapter of this mystery, the James Webb Space Telescope. Orbiting 1.5 million kilometers away from Earth at the second Lagrange point, Webb possesses ultra-sensitive infrared vision that can see details no other telescope can detect. In mid-2023, Webb turned its giant gold-coated mirrors toward Saturn, capturing a breathtaking image that looked almost completely surreal. In Webb's infrared filters, Saturn itself appears extremely dark because methane gas in its atmosphere absorbs almost all the sunlight hitting it, while the icy rings glow with blazing brightness. The data gathered by the James Webb Space Telescope has provided researchers with a brand new, highly detailed map of the chemistry inside Saturn's rings. Webb's near-infrared spectrograph can measure tiny variations in the temperature, thickness, and purity of the ice particles across every single ringlet. Early analyses of this data suggest that the ring rain might not be a steady, constant stream, but rather an active, seasonal cycle. As Saturn moves through its nearly 30-year journey around the Sun, its tilt changes the amount of sunlight hitting the northern and southern faces of the rings. When sunlight hits the rings at a steeper angle, ultraviolet radiation increases, charging more ice particles and accelerating the rate of ring rain. When the rings are tilted edge on to the Sun, the charging process slows down, giving the inner rings a temporary breather. Webb's data is showing that Saturn's upper atmosphere is constantly changing its chemical balance based on how much water is being pumped into it by the rings at any given moment. The rings and the planet's atmosphere are locked in an intimate, dynamic conversation that changes from decade to decade. Astronomers are also using Webb's infrared eyes to search for faint, undiscovered structures in the outer ring system. They are looking closely at the distant E ring, an enormous, diffuse cloud of icy vapor supplied by the geysers of the ocean moon Enceladus. Enceladus shoots hundreds of kilograms of salty water ice into space every second from cracks in its south pole, constantly feeding fresh ice into Saturn's outer boundaries. Webb's instruments are helping scientists determine whether Enceladus could ever replenish the inner rings, or if the drainage rate is simply too massive to overcome. Do you think future human explorers should attempt to land robotic probes directly on the icy boulders inside Saturn's rings? Leave a comment below with your thoughts on space exploration. And be sure to subscribe, so you stay updated on all the latest deep space missions. The latest mathematical models, combining data from Cassini, the Keck Observatory, and the James Webb Space Telescope, paint a grim picture for the future of the rings. The water loss from Enceladus is nowhere near enough to offset the torrential downpour falling into Saturn's atmosphere. Enceladus acts like a tiny dripping faucet, trying to refill a swimming pool that has had its entire bottom knocked out. The inner rings are running on borrowed time, losing mass far faster than any natural process can replace it. Scientists are now combining these multi-observatory datasets to calculate a final expiration date for Saturn's rings. The most recent estimates indicate that the inner rings could completely disappear in as little as 100 million years. Even if you take the most optimistic, slow-drain scenarios into account, the entire main ring system is unlikely to survive past 300 million years. That means Saturn's iconic halo is a temporary, fleeting gift that is already more than halfway through its total lifespan. To understand why this discovery is so profound, you have to realize that our place in time is an extraordinary cosmic coincidence. Humanity evolved, built tools, invented telescopes, and developed space travel during the exact tiny window of cosmic history when Saturn happens to wear its brilliant crown. If our species had emerged 300 million years in the past, or if we had emerged 300 million years in the future, we would look out at a solar system with a plain, ringless Saturn. We are living during the exact golden hour of Saturn's visual majesty. This realization also completely shifts how scientists search for and study planets orbiting distant stars outside our solar system, known as exoplanets. Over the past few decades, NASA's Kepler and TESS missions have found thousands of alien worlds scattered across our galaxy. Astronomers used to assume that giant ring systems like Saturn's were rare, permanent wonders that only formed under very specific conditions during the birth of a planet. But now, we understand that rings are dynamic, temporary phases that giant planets go through multiple times in their lives. A giant planet might capture a passing comet, tear apart a moon, or collide with an asteroid, generating a glorious ring system that lasts for 100 million years before draining away into the planet's clouds. Millions of years later, another orbital shift might send another moon crashing into the Roche limit, creating an entirely fresh set of rings. Planetary rings are not permanent monuments carved into the solar system. They are shifting, breathing cycles of creation and destruction. The universe is not a static museum, but a wild, constantly evolving engine. In 2012, astronomers discovered an exoplanet designated J1407b, located roughly 430 light-years away from Earth. This massive alien world possesses a ring system so colossal that it spans 90 million kilometers across, which is roughly 200 times larger than Saturn's rings today. If J1407b replaced Saturn in our sky, its rings would dominate our night sky, appearing many times larger and brighter than the full moon. Scientists now believe J1407b is simply in the earliest, most explosive phase of its own ring life cycle. actively condensing and shedding material just as Saturn did tens of millions of years ago. When we look at other planets in our own neighborhood, we can see the ghostly remnants of this very same process. Jupiter, Uranus, and Neptune all have faint, dark, dusty ring systems that are barely visible even to our most powerful space probes. For a long time, scientists wondered why those three gas and ice giants had such pathetic, dim rings compared to Saturn's bright white spectacle. The new discoveries provide the missing answer. Jupiter and Neptune are not missing out on rings. They're simply at the end of their own ring life cycles. Millions of years ago, Jupiter or Neptune might have possessed bright, dazzling rings that would have put Saturn to shame. Over countless millennia, their own magnetic fields and gravitational forces drained those icy rings down into their atmospheres, leaving behind only the dark, dusty soot we see today. In fact, some planetary scientists believe that Mars might join the ring club in the future. Mars's inner moon, Phobos, is slowly spiraling inward toward the red planet by about 2 centimeters every single year. In roughly 30 to 50 million years, Phobos will cross the Martian Roche limit, shatter into billions of pieces, and give Mars its very own ring system. Earth itself may have had temporary rings in the distant past. When a Mars-sized object named Theia slammed into the young Earth 4.5 billion years ago, the impact blasted enormous amounts of rock and molten metal into orbit. For several thousand years, our planet was surrounded by a glowing, superheated ring of debris, before that material clumped together under gravity to form our moon. Ring systems are natural stages of planetary evolution, appearing and disappearing like storm systems across cosmic time. Every single thing we observe in the cosmos has a beginning, a middle, and an unavoidable end. The fact that something as massive, ancient, and breathtaking as Saturn's rings can completely vanish reminds us of the fragile moving nature of the solar system we call home. We often view the night sky as a timeless painting that never changes, but the truth is far more exciting. The universe is actively changing, breaking, rebuilding, and reshaping itself while we watch from our small blue world. If you enjoyed uncovering the true, untold story of Saturn's vanishing rings, please take a moment to subscribe to the channel and turn on all notifications so you never miss our deep dives into the cosmos. Drop a comment below answering this question. Do you think humanity will ever build spacecraft capable of seeing the birth of a new ring system around another world? Be sure to share this video with a friend or family member who loves space and science mysteries. Thank you so much for spending your time with us today, and we will see you next time.